Okay, I was told that we can start. Hello everyone, welcome to this session about Java 12 and Java 13. I really hope you enjoyed the party yesterday and had a good night's sleep, because now we're going to stick to Java 12 and 13 for 2 hours. So I hope you have enough power, also mental power, for this deep dive. So this is the title of this deep dive, Java 12 and 13, what's new and noteworthy. My name is Piotr Przybył and we are at Devoxx Ukraine, obviously. So shortly about myself, this is my name. I was told that it translates to Ukrainian as Piotr Przybył. So you can send your feedback, questions, comments or hate at either at email or you can tweet me. I'm self-employed as remote freelance software gardener, which might be important because there's this role of software gardener. Who knows what software gardener is? What's this position? Okay, so software gardener is not just a developer, it's someone who takes care of a software or of a system just as if it was a garden, to get rid of the bugs, to plant new plants, to get rid of the old plants. We have seasons, sometimes you need to destroy a large part of the field to start with the green field and so on and so on. I also work as a trainer. I give trainings for a few companies, one of them being Cementhis. What might be important for this talk, I'm mostly Java developer. I also do Scala, but I'm mostly Java developer, most of the time on Linux. And sometimes I say I'm haunted by Java, because even when I go on holiday to Spain, Java is right behind my back, so I can't get rid of it, even on holiday. Sorry. Question is, who are you? Who in this room is Java developer? Okay. People from other JVM languages like Groovy, Scala, Kotlin. Okay, we still have a few. Cool. Are there any non-JVM developers in this room? Nobody. Okay, cool. Also, I'd like to know which version of Java are you using in production? Java 8? Okay, many. Way too many, I'd say. Sorry. Java 11? Oh, quite a few guys. Who has tried Java 12 and 13? Just 3 hands raised. Okay, cool. Who prefers voting with left hand? And who prefers the right hand? Cool. Okay, you prefer right hand. Okay, we did that voting. Okay. So agenda for today. First, I will describe you the concept of preview features, because it finally has been utilized with Java 12 and Java 13. And then, of course, we'll deep dive into Java 12 and Java 13's features. So short reminder first, in case you haven't seen my talk yesterday. There's new release schema for Java versions, for major Java versions, so we're not waiting anymore 2 years, 3 years, 4 years for new Java version. Now a new Java version is released every 6 months, and it's not postponed by the features, meaning if a feature doesn't make it to a certain release, it's not merged or it gets unmerged. It's just nobody's waiting for a feature, for a JAB, GSR, or whatever we name it, to be ready. The dates are fixed, and either the feature makes it, or the maintenance of the feature, or it doesn't. It has to wait then. And Oracle JDK Oracle Corporation, for their JDK, known as Oracle JDK, releases LTS, meaning long time support, every 3 years. So we had Java 11 September last year. After 2 years in September, we're going to have Java 17 and so on. So it's long-term support from Oracle's point of view for Oracle JDK. And this also means that there's instant lack of support for OpenJDK from Oracle's point of view. Once Oracle releases a version N of OpenJDK, they stop supporting version N-1. We saw that. That's why Java 9 or 10 or 12 is de facto not supported by Oracle anymore. However, there's Adopt OpenJDK, which does it. So there's this beautiful life cycle chart from Azul, and you can see these gray boxes here. They represent basically OpenJDK. These are the publicly available builds. And if you'd like to stick to free OpenJDK from Oracle, you have to upgrade every 6 months. That's why it's called support cliff. Or you can switch to this pinkish approach, I would say, which means you pay Oracle to have a stable and maintained version of Java, so you don't have to jump to a new version every 6 months. That's why you can have this triangle to choose, so you have stable, free, or secure version, and you can choose up to 2. Meaning, if you like to stay secure, I mean to have all the bug fixes and so on still present, you either have to be, or if you choose to be free, meaning staying with OpenJDK, then you have to upgrade every 6 months, therefore you're not stable. Or if you want to be stable, then you're not free because you have to pay Oracle for this. But I mind you here, everything says Oracle, Oracle, Oracle. So it's only for Oracle's JDKs, okay? But we need to remember that there are also other JVMs and other vendors behind these JVMs. So you can repeat after me again that Java 11 is not paid, because this is the common rubbish I hear every now and then, or I read it in forums that people keep saying that Java 11 is paid. Oracle JDK 11 Plus from the Oracle is paid. They switch the license model and so on. So now we have to pay Oracle if you want to have Oracle's JDK in the production. But you don't have to pay for Java 11 as it is itself. I mean, you can follow this link. You can see that Java is still free because it's licensed under GPL v2. And that's pretty much it. By the way, who has read the license of Oracle JDK version 8? Okay, there's one guy. Okay, I have jellies for you. You're the first guy who read that. Try to catch. Almost, sorry. Okay, so I didn't read this license as well, but the people who did that say that we had to pay for Oracle JDK previously as well. Only it was free for like PCs, for servers, roughly speaking, but it wasn't free if you like to, let's say, wanted to run a Java ad, let's say a info kiosk or something like this. Then you had to pay for Java as well, even for Java 8. Okay, so it's not a super duper introduction of payment like being free previously. It's not the case. It was paid previously as well, only in a different model. Yeah, but there are also, remember, other vendors and other JVMs. So if you really like to try new stuff for free and you're afraid of being abandoned soon, you can go to Adopt OpenJDK. Maybe I just zoom it a little bit. Let's see if this zooming works. Yeah, so we can go for Adopt OpenJDK for their page, and you can choose various versions like OpenJDK 8 or hopefully not, or 11. How does it work? So there's a kind of consortium which works this way. When Oracle abandons OpenJDK, they start carrying of the system, I mean of the OpenJDK. That's why Adopt OpenJDK is still LTS, because as far as I know, Red Hat is still backporting all the bug fixes and so on. Therefore, Adopt OpenJDK from this point of view acts as an LTS. And it's almost identical technically to Oracle JDK. So yeah, you can then go and select the platform that suits you. You can select Docker. As you can see, you can select various operating systems, or you can select Windows. It's up to you. All right, so there's this question. Shall I migrate to Java 13, or should I stick to the latest LTS? And instead of 13, we could say 12 and all these other versions which are not LTS. It's a good question. It's a valid question. Shall we try to migrate to all these non-LTS versions, or shall we only jump between LTS versions like 11, 17, 23, and so on? So the answer is it depends. I see consultants laughing. Okay, that's cool. So, is it okay, is it worth it to migrate to a non-LTS? One aspect is this support cliff. That you have this support cliff for OpenJDK, so you have to upgrade every 6 months, provided you want to stay up to date and secure and so on. Or you have to select or find de facto a LTS vendor, like Adopt OpenJDK, or as far as I know, Azul is also supporting all these minor versions. I mean, sorry, not all, but at least some of them. Like I think they said that they will be supporting Java 13, Java 15 as well, just as if they were LTSs. So you need to find someone who will keep your JDK up to date, or you have to deal with this support cliff, right? But there are cloud providers. If you're hosting your application in-house, if you own the servers, you can install whatever you want. But if you're hosting your application from the cloud, chances are they will have just 8 and 11 for time being. I can even show you that. Let's see this SDK list, Java. See, yeah. See, there's like from Adopt OpenJDK, you can have all these versions, whereas for Amazon, you can only have 8 or 11. They don't bother with like 12 or 13. So if you're cloud hosted, then you won't have this LTS versions, perhaps. Some people say that especially Java 12 and Java 13 are interesting because of the preview features. Like some people are so eager to use switch expressions or text blocks. Thing is, if you compile your code to use preview features and you deliver such class files, even if they're packed in a jar, to run it, people need to enable the preview features in their runtime as well. So making a code depending on preview features, like the production grade for the others, might not be a good idea. Just as the name says, it's a preview feature. And if you use the preview features in your code, like for Java 12, for example, even if you use syntax which doesn't change, or if the syntax of the feature doesn't change, but the feature is no more preview but becomes like a standard feature, then you need to recompile this code as well, because there might be source compatibility, but there's no bytecode compatibility. So this means if it was working okay, let's say for Java 13 with text blocks, and we observe no changes regarding text blocks for Java 14, you will have to recompile your code as well for Java 14. I'll show you why in a minute. But there are, of course, some benefits. You can get benefits from better performance, for better GCs, like you can try Shenandoah or ZGC instantly, or the new features they have, like giving the memory back to the system. You don't have to wait for Java 17. A perfect example is what I mentioned yesterday, these compact strings from Java 9. I mean, some companies, instead of waiting till Java 11, jumped to Java 9 instantly from Java 8, despite 9 being not the LTS version, because of the compact strings. Because if they had huge heaps packed with strings, and all these strings were, or many of these strings were in ISO Latin 1 scope, then they had cut the string utilization in of the heap in half, basically. So for example, we saved, thanks to that, let's say 4 gigs out of 24 gigs. So it was 60% of a gain for nothing, for free. We didn't have to change anything. So you see 16% performance or 16% less GC pulses might be worth it. Just you can get better performance with these non-LTS versions. And of course, as Professor Horstman said yesterday, you should provide your feedback, or we should provide, better said, the feedback of the preview features. How do we find them? How do they perform in our production code bases? So we like, give it a try, give it a spin. I totally agree with Professor saying that, you know, doing it at the stage of preview might be a little bit too late. So you should be already trying the record types and other stuff, and like sharing your experience, your point of view, like, I don't know, mailing the maintainers and so on, because they're eager to get our feedback, the results of our preview. That's why it's called preview. Okay, we should preview the features in the versions they propose, and we should provide our feedback, basically. And last but not least, there's this concept of eating elephant in small pieces. There's a joke, kind of a riddle in Polish, how to eat an elephant. And the answer is piece by piece. Okay, so if you're jumping, or if you plan to jump from Java 11, provided you're on Java 11, directly to Java 17, it's going to be a huge jump. Okay, because you will need to cover 6 major versions. But if you do that, Every 6 months, in a tiny baby steps, piece by piece, it's going to be perhaps easier. Or you won't have, like in 2000, what year is going to be? 3 years from now, 2021. I'm not that good at math, sorry. Then you have to have this huge jump, or like some companies had this huge jump from Java 8 to Java 11. Sometimes it's better, I mean, it depends on the product, of course, of the system, of the code base, to do a little steps, like go first to Java, let's say 9 or 10, and then jump to Java 11. And the same with this, like jumping from 11 to 17 might be a really huge jump. So maybe you'd like to divide it into smaller steps and do these steps already when they're possible. Okay, but we need to remember one thing, that these non-LTS releases and the preview features aren't monkey soft. Because some say, oh, it's only the LTSs that matter. The rest is like rubbish, kind of preview, monkey soft, banana soft. I've heard many descriptions. No, they're not. I mean, at least basing that on the promises or messages from the Oracle, these are like totally valid and solid releases, and even the preview features aren't like dirty or cheap. They put much effort to make them like production grade, only they are not totally sure if this is the best version of a feature. That's why it's preview features, so they can roll back or change it in the future. This happened to switch expressions, for example, between Java 12 and 13. But these are like totally optimized at the compiler level and so on. So these are not monkey soft. Okay, so Java 12, it got released. Sorry, there's a mistake. It should be 2018. No, 19. Sorry, it's okay. Yeah, but it's obsolete now. It's March this year, and it had these JEPs. We'll cover most of them. And of course, then there are two minor releases based on the new schema. So the first came a month after. That's why it's 12.01. And it had this concept of the new Japanese era, because the previous emperor decided to retire. And in Japan, they count years in, or they have the era-based calendar, right? So in the second year of Emperor X. That's why since, and from our calendar, May the 1st in Gregorian calendar, they have a new era called Reiwa, if I read it correctly. Sorry, I don't speak Japanese. And then there was another version released 3 months after. It also had some bug fixes and security issues covered. Then there was Java 13, which got released a month and a half ago with these JEPs. And I think we are going to cover, almost all of them as well. And and even though like a month later, like 2 weeks ago, we had another minor release of Java 13. And see, it had some improvements. If you're the happy Mac owners, the Catalina stuff probably, so they were addressing this already. So you see if there are issues with something, like new things pop out, they're being addressed like regularly by Oracle and friends. There are release notes of Java 12 and Java 13. Slides are online, so you can click that links and read the whole list. They explain in detail every JEP, every JSR, and so on. So there's a huge list of the changes, deprecated stuff, removed stuff, new stuff. I really recommend for you to at least skim the list. Okay, so let's talk about the preview features. If you guys have questions, just please interrupt in the middle, okay? Because this is more like, let's say, this, at least in my imagination, this deep dive is kind of a, let's make our hands dirty. It's just me who has the computer. It's not a proper workshop, but we can experiment, we can do stuff. So we have any ideas, questions, comments, please interrupt immediately, so we'll try to cover them, okay? So the preview features, they are implementation of JEP 12, and they are about this switch in command line interface, enable preview. So the enable preview is not about cherry picking of the features. So if there are, let's say, 2 preview features or more than just 1 preview feature, like we have in Java 13, you can't say, okay, I select this feature, but I don't want to select or enable the others. It's not this way. It's all or nothing. You enable all preview features or you don't enable any preview features, basically. Versions of these preview features need to match. I mean, you can't compile preview feature from Java 12 using compiler of Java 13 and run it using Java 14, for example. Everything has to be in the same version if you're using preview features, okay? So the feature has to be preview feature in a given version of Java, the compiler has to be of this version of Java, and when you run it, it also has to be this version of Java. I mean the major version. And how to use it? To use it, you just need to add this enable preview to Java C to compile and to Java or J shell, of course. Like in here also, if we have like build tools like Gradle or Maven or in IDE, we have to enable, we need to tell these tools that we are going to enable to use to allow the preview features. So it has to be done explicitly, basically. Okay, so in Java C, we do it this way. Because enable preview alone, like this switch is not enough. You also need to say for which major release you enable it. So you need to use both of them, of these flags. Sorry, enable preview and release. Instead of release, you could also use source, because release is de facto like setting source and target together. So instead of two switches, you can use just one switch. And release is mandatory, or source is mandatory if you use enable preview. Because the compiler needs to know that you're sound, that you don't have any mental issues, you know what you're doing, and that you're enable preview features of certain major release of Java, basically. Well, maybe we can try to do this in terminal. Let's see. Let's go into this src main Java. Do we have some code here? Yeah. So let's Java C. And there should be like app, and let's enable preview features, enable preview. So see, if I try to do this, I'll try to make it slower. Yeah, maybe this is better to view. See, yeah, let's make it wider. Yeah. So if I only use enable preview without setting the release, the source or release, then Java C is going to complain. I need to set the version. So with, for example, release 12, then it compiles, right? Yeah. And it emits a warning which can be disabled if you're compiling a code which really has these preview features enabled. So, for example, this code doesn't have is not using any preview features. But let's compile another file like lessons checker, and then it emits this warning. See that this file uses preview language features. There's this warning from compile, and as far as I can tell, it cannot be disabled. Like, you will get it always when you compile a code with preview features. And this is written to a version of the class in the .class file. Because when you have this class file, there's a version saying which version of the bytecode this is. And it's 44 plus the number of the Java version. So for Java 12, this is 44 plus 12. This leaves us with 56, right? And for Java 13, this is 57, and so on. This is the version of the bytecode stored in a .class file. And it's written to that file. And if we use the preview features, it's stored this as well. See, do I have this class file somewhere in here? Let me check. Yeah, it got compiled here. So let's try to run it without this enabled preview. Sorry, we'll do that from scratch. Java and then org. Yeah, and lessons checker. And it even complains. See? Because it's unsupported class version error. Because it detected based on the class file that it was compiled using preview features. So how does it work? Yeah, so if we enable preview features, and we set that the source is 12 of this source file, we have this warning emitted, and it works. So we can do it as well. As you can see, it's not. I'm not using. I will need to remove this text. Sorry, class files to make it work. Because I'm also using. I'm not using Java-C right now. I'm just using Java for a simple program. See, it also emits this warning. And can't find main method in the day of the week. Yeah, of course. Nevertheless, this is how it works. You see this warning. And for Java-C, as I have shown you, if you try to compile it and you don't set the version, the enabled preview, or maybe we can do this again. For Java-C, even if I try to just Java-C without enabling preview, the compiler detects that there are some preview features being used. See, switch expressions are a preview feature, and I disabled by default. So if you have preview features in your code and you don't enable them, they won't be compiled. Enable preview alone doesn't work, so we have to enable preview with the source you're targeting. And if, as I have shown you, if you try to run the code compiled using the preview feature, if you don't enable, we've enabled this for the compiler, so the compiler knew it was preview feature for Java 12, but if we don't do that for the runtime, then the runtime will refuse to run it, because we need to explicitly enable preview feature as well, only not setting source or release. And how is it being detected? It works like this. Normally, if you don't use preview features, the version of the class file will be just 56 or 57 for Java 13. But if there are some preview features, then there is 65535 added at the end as the kind of indicator, like a marker. That's how the runtime knows that a certain class version uses preview features. And also, that's why this won't work with the newer version of Java, like this. If we have Java 12, here set, and if we run this of the compiler of the Java, and if we then switch to Java 13, and see it's Java 13, and we still try to run it, being compiled for Java 12, it doesn't work, because it says that basically when you translate it to a human language, that this class file is compiled and it's using preview features of Java 12. This is what it says, this version indicator. Because it's 56 is for Java 12, and this means preview features. So it says that this runtime cannot handle preview features because it's not preview feature from Java 13. That's why you need to recompile preview features for every new version. There might be source compatibility, but for sure there won't be bytecode compatibility. You need to remember that. So to set that in Gradle, you can just have to set enable preview for compilation, for runtime, and for testing. Of course, just as if it was a CLI. In Maven, you have to set it as well, just as if it was a CLI, C, compiler, args. For various plugins, you also have to set it, this enable preview, and so on. There is no global switch in Gradle or Maven. Okay, this build is using preview features. There's no such thing. You need to deal with all these locations, basically. And in IntelliJ IDE, it can be done like this. You can set the project version, because it can't detect it based on the command line arguments right now. It can't detect it, so you have to set it explicitly to be Java 12 preview. Not just the standard version without any language features. One thing I'd like to mind you is just when you set it for project, it's not being set automatically for the modules. So let's try to make this experiment, because for some folks it's frustrating. Let's re-import it from Gradle. Loading, maybe it won't work, we'll see. See, it doesn't work. It complains that it's not set as a, switch blocks are not supported on language level 12. So I go here, I set the version of the project as, you see, it has the previous switch expressions, but the code doesn't work. So what the heck? The heck is you have to go to module And for the module like this one, you have to set this explicitly only. IDEA warns you that it's not going to work once you re-import the project again. Some say it's a bug, some say it's a feature. Nevertheless, this is the behavior, okay? So don't get frustrated, just check the language level for the module as well if you're experimenting with preview features, right? Okay, so let's go to the switch expressions. These are preview feature. They got introduced in Java 12, and they also got updated in Java 13. That's why the preview feature in Java 12 and Java 13. And there is this difference between statement and expression. So, yeah, let's say we want to update the value of value. I hope you have wiser names of your values and variables in your code, of course. Like naming something value is stupid, of course, but it's for demo purposes only. So if we have something Boolean, then we can set the value of 12 if it's true and 17 if it's false. And this is if statement in Java. There is also this ternary operator which works like expression de facto. So you can have this something Boolean, and when it's true, you like yield or return 12. In the other case, we return 17. So this acts as an expression because this thing has a value, whereas if doesn't have a value. That's why if is a statement, and this ternary operator can be treated as an expression. Sorry guys, I couldn't resist. This is how it works in Scala. In Scala, everything is an expression. So that's why in Scala, we don't have this ternary operator. We just have a proper if, and this if has a value. So this branch has a value of 12, and this has the value of 17. See, much simpler, I would say. Okay, back to Java. So this is the switch statement we know, right? So we're switching over the day, and on Monday, Friday we have 6 lessons, on Tuesday we have 7, on Thursday and Wednesday we have 8, and then we have no lessons on weekend, of course. And this is what we know, right? This is like the C++ style, I would say. It was with us since the beginning of Java, and yeah, it's like used to set the value. This is kind of a variant of this go-to with predicted branches and so on and so on. I mean, I'm not going to dive that deeply. And these are the switch expressions introduced in Java 12 with breaks. So first thing you should notice is that we assign the value of this switch to something. So this means that this switch, this construct has a value, right? And when we keep switching over the day, on Monday and Friday, we can break with 6, then we can break with 7, then we can break with 8. I'd say it's kind of overuse and not even abuse of this break keyword, right? Because what does it mean to be breaking with 8? And this was one of the arguments why they switched that switch in Java 13. Of course, we don't have this intermediate. We don't need to have this intermediate value. We can just return it immediately. See, so it just has a value, and we return this value. Let's say from a function, and yeah, we can have defaults. See, so by default, we don't have any lessons, basically. This is the default branch, and we just break with 0. In other cases, we just have a value. And we can also switch, like using these primitive types, enums, strings, and like the big integer. And that's why they changed that in Java 13. In Java 13, we don't have anymore this break to break with a value. We just yield the value, which in my opinion makes much more sense, because what was the meaning of breaking with 6? Break with 6, I mean, I wasn't in a relationship with 6 to break with it, right? That's why now we yield 6, and it looks similar. If you're a Scala developer, it looks similar to for comprehension, right? You're yielding something. And I think it's cool. It was a good change. Yeah, it's still just, I don't quite get it why it's still called switch. I think we should left switch as it was, like the switch statement, and we should have something new for these switch expressions, because in the long term, the switch expressions are meant to be the Java version of pattern matching. So I don't know why pattern matching should be switching. Pattern matching and switching are different concepts. So nevertheless, we have the switch used as the keyword, and yet there's another syntax. It was available in Java 12 and Java 13, and it looks like this. I call it the lambda style switch expression. It works like this. So for Monday and Friday, I'll just have the lambda which returns with 6 and 7 and 8 and 0. As you can see, this is much more concise, and it really starts looking like a pattern matching, right? Like the proper pattern matching, except we have switch in here, not match like in Scala. So the switch expressions must be exhaustive. I can show that in code. Let's go to the code. I have this lessons checker, and because I want to show the error. So we have the switch expressions, and they need to be exhaustive. And see if I don't have a default branch for integers, or I don't cover all branches using like enums, then there's an error, and it says switch expression does not cover all possible input values. Obvious. So with this lambda style, I need to cover everything. So I either add this default, like here, or for this style with this enums, I list all the enums, because let's say I forgot to list Saturday, it will complain as well. It doesn't cover all the possible input values. So switch expressions with lambda style need to be exhaustive. That's why I prefer this arrow style or lambda style, whatever we call it. So this is more lambda style, and by default it has no fall through. So if we go just no fall through. So if I'm in this, if I was in this branch, or if I'm in this branch, you see I don't need to add this break, right? So it's like in pattern matching in Scala. So it's like switch expressions in .NET. Sorry, in C#. So I'm just once I get into this, let's say Monday or Friday branch, it's obvious it's going to be this branch only. It's not going to be anything else, right? So I'm not going to break with 0 at the end. But blocks are still possible. This is an example of such blocks. Like just for lambdas, I can use blocks. So I can also use blocks for this switch expression. See, so these are simple cases, and for this weekendish case, I want to log something, for example. So I want to sublime my frustration. Why even you're asking me that? It's obvious. On weekend I don't have lessons, right? So if I don't want to do two things, I can just log something before yielding this value. This is of course Java 13 syntax. In 12 we had break 0. And return is not allowed in switch expression. Okay, so for this case I have input +1. Here I want to just return what I got as doubled. And I can't use return because this would be ambiguous. The compiler doesn't know in such syntax if I want to return from just this switch or from the whole method. That's why it doesn't work. That's why we have to use had to use break or yield. Maybe I'll have an example with this return. Let me see it so you can see this error. Return from switch doesn't work. Let's see what it says. And it says, sorry, I have a new keyboard. Yeah, and it says return outside of enclosing switch expression. So, yeah, just as I have told you, you can't return from switch expression. But this might be a little bit surprising. It's still possible to return from switch statements. And you might be wondering, okay, but there is this lambda style, right? And this is a switch expression. How is it possible, right? So see, the thing is, from this switch, I'm not assigning the value to anything. That's why the compiler thinks it's a switch statement, not switch expression. So I'm using this lambda style with switch statement, so I can still return. That's why I think setting or using this feature with switch is a just bad idea, because you see how much confusion it brings, basically. Yeah, I see your faces. My face looked just the same when I discovered that. Like, what the heck, right? So I have like a block here, block here, block here. I can return. I can't yield. I mean, yeah, because I'm not setting it to a value. So it's switch statement, not switch expression. Interesting, right? Okay. One thing, switch expressions don't define their type. I have an example, should have an example for that. Let's see. Yeah, this one. See, so we generate a new random value. We can do that in JShell, why not? Let's do that in JShell. See, let's use JShell. And I need to enable preview, because if I don't enable preview, it won't work, of course. I just pasted this piece of code, and we have this method created. So now let's call this method, and see we have, that's just, we got something very small, and therefore what we got from this switch is actually, here we are printing the class name of what we got. It's a string, right? But once we do it a few more times, yeah, this time we got 5, so we got integer. So this time the switch expression has yielded integer, not string. So you might be wondering, so what's actually the type? Is it like string sometimes or integer sometimes? How does it work? Well, it works just like the var type inference. The lowest ancestor, like in the hierarchy 3, is found, and this is the type of this value. So if we do it in the code, and instead of var, I need to put, what should I put here? Sorry? Okay, object would work, but everything is an object. This is a trivial. Okay, let's say what the compiler would put. Let's try to go down with this inheritance tree. Shed it out. Sorry? Integer? It won't work, but you can try integer, see? Because here we're turning string. If we put string, it doesn't work from this branch because we're returning integer. So how did it work in the JShell? What was the type of this stuff? I guess it was serializable, because it's the lower common ancestor of both integer and string. That's why you're not forced to just return one precise type. You can use just, whatever is working for both branches in this very case, or you can yield more types, of course. I'm not trying to tell you that this is the style you should necessarily follow. It's just I'm showing you the possibilities of the language, of the feature, and of the compiler, right? Okay. Back to the slides. There are plans to evolve towards pattern matching, and there's a very nice article written by Brian Getz, and it's here. Yeah, so we can get a taste. See, we all know this dreaded style of instance of stacked one under another, right? I'll zoom it in. Okay, the idea is so we can go this style, so we can say it's integer of type I. So here I can use the I instead of doing this bloody casting, because it's obvious that once I'm in that branch, it has to be a string, right? So I can put this S here and then just deal with S. So I can skip this. I can skip this line, and yeah. So this would be useful for like equals. See, for this formatting, but instead of having this dreaded construct, we can go like this switch expression style or switch statement style with lambda, with this right arrow. Okay, so this is the reason why it's evolving this way. I'm not quite sure I understand why it's called switch or not match, when you can see that the whole article is about pattern matching, not pattern switching. Yeah, so some constant patterns. So also we could have this interface being, yeah, so we have this, do you know the unapply method from Scala or deconstruction in general? So we can like have a deconstructions, and therefore for visitor pattern this would be much easier. So eventually we could have something, yeah, quite resembling pattern matching from Scala. So we have int node, neg node, and so on, and we can just get what's inside. And even instead of precise types, we could use vars, but it's not covered here. Yeah, it is. See, so maybe in the future we'll be able to use vars, and this is the reason for switch expression to be working this way in Java 12 and 13. So in the future we might get something like this. Yeah, there's also about nesting and so on. And interesting thing that maybe in Java 14, I mean, it looks like in Java 14 we'll finally get record types which will be quite similar to data classes from Kotlin or case classes from Scala. I mean, they'll not be exactly the same, but it would be a good reason to finally eliminate Lombok. So for record types, if we'll add this, yeah, instead of this, you know, creating this simple POJOs or value objects or DTOs, we'll be able to set it as record, and then all these methods and the construction will be generated for us. Therefore, having these record types would be that simple to use them in switch expressions. Okay, so then you don't need to generate this unconstructors on unapply methods and so on. So switch expressions combined with record types could be quite useful tool. So in the future versions of Java, we could be probably will be able to use something like this. Okay, questions? Do you have any questions to Spring expressions? No questions. Okay, let's go. Text blocks. They are a preview feature as well. And yeah, they were introduced in Java 13, and they are implementation of JEP, of this JEP, if you like to. I mean, have you ever read any of these JEPs? Because they are not that techy, in fact. I mean, they're quite simple. See, you can dive, and they are like summary, the history, what's the goal, what is not the goal, and so on. And there are some motivation and examples. So these are really interesting. I mean, they are not like these RTFs or so, how is it called? Like RFCs, sorry. These are not like these RFCs, these are more in a human language, right? So I really recommend you can actually follow these links and browse these JEPs. Yeah, so we have this poem by Adam Mickiewicz. I mean, every nation says, like Paul say he's Paul, the guys from Belarus say, but he was born in Belarus, so he has Belarusian origins. But because he started one, like the greatest of his poems, but Lithuania, my motherland, the Lithuanians say that he was Lithuanian. Anyway, he wrote this first poem of his, this Ode to Youth, or Oda do Młodości, in Polish, and this is the way we construct strings, right? Using string literals. These are string literals. We have 4 of them. We had to add this \n to have a new line, and this is how we put half of a verse. Excuse me. So this is what we know. By the way, this is still working in 12 and 13. This syntax is not going anywhere. So I said it's in 11, but it's of course also valid for 12 and 13, right? And this gets more complicated when we want to do this for like, let's say JSON. To have these tabs, we do something like this. To have new lines, we have to escape the double quotations and so on. It's ugly, right? So a solution for this might be to use text blocks. Yeah, reach where your site doesn't reach. The first verse says, basically. See, it's a bit simpler, I would say. You have 3 opening quotation marks, you end with 3 quotation marks, and you just go verbatim, at least for such a simple text. And it gets even more appealing for JSON, right? This is much nicer, I would say. Don't worry about the coloring. I mean, this JavaScript plugin for coloring Java's syntax, just, you know, it can't understand Java 13. So don't worry about the coloring in the slides, but this is how it looks like. You have this author title written and the actual content. Who thinks it looks better than the previous one? Yeah, almost everyone. So still some folks addicted to the old style. Cool. Yeah, so the rules for text blocks. Text block needs to be opened by 3 quotation marks. And it has to be followed by a new line. If you don't follow by a new line, it won't work. And it has to be closed by 3 quotation marks as well. And it can be closed like everywhere. It doesn't have to be a new line or somewhere. Just you can close it as you wish. Let's do that in JShell again. Only this time for Java 13. JShell enable preview. And we can go like var test equals 1, 2, 3, new line. And we can say hello and 1, 2, 3. And here it is. It doesn't look different from the literal, right? So we can do even var test 2. And we can say hello. And you might be wondering if they're different or not. So we can test equals test 2, and they're equal. And what might be a bit surprising, we can go even this. They're also equal referentially. So once you create or instantiate a text using this text block, not using string literal, under the hood, let's say in runtime, it's just an ordinary string. Text block is just a new way of creating a string, basically. So once you create it, there's no magic. As you can see, it behaves just like every other string. Position of the closing matters, unfortunately. I mean, this is one of the 2 most confusing things about text blocks. I mean, being also a Scala developer, I really don't comprehend why they couldn't just go the Scala way with the strip margin and so on. Anyway, we are when we are. And yeah, as I told you, once they create it, it can be used just as string. And these are some examples. So I can't zoom it. Okay, so the first line doesn't compile because in this very place here, we don't have new line. Right? We can JShell that. I mean, this is why we have JShell after all. Finally, we have REPL, so we can see how it works, right? See, it doesn't compile because missing line terminator. If we, yeah, I can show that IntelliJ. I mean, these bloody car testers. Okay. Okay, we have. Where do we have it? Sorry, it's Java 13, of course. Yeah, so this one, so we have it in, sorry, wrong file. We have it in text blocks. So because there's a better coloring, that's why I want to show it here. And this doesn't compile as well because there is no matching closing, right? See, it still interprets it as a part of the string. That's why I would need to add 3 double quotation marks to make it compile. Okay, so in order to print 3 quotation marks inside, I need to escape one of them. The first one, the second, or the third one, basically. I think the best style would be to escape the first one, so as you can see, the escaping still works. So we can run it here. See, sorry. What does it say? Cannot find symbol. Because I don't have this print line method defined, so we can define it. Oh, we can. Okay, let's. Oh, wait. All right, let's do this because I just use it as a kind of a alias here. So see, I have printed 3 quotation marks. I just had to escape one of them. And I think it's the best idea to escape the first one. If you have 4 or more, of course, you can't have 3 consecutive quotation marks. This is the trade-off for selecting this as a kind of a operator or something. This is not indented, yeah. See, no indentation here. Also, these two won't get indented as well. But they are indented, right? No, they aren't. These are intended like these three. Let me paste them here. See? We have one indentation, and here we have like even double indentation. So I'll show you in the next slide how it works. And see, you don't have to close it in a new line. The closing can be on the same line, so it works like this. Right? Only we don't have this new line in here, and we can have many empty lines as well, because why not? See, many empty lines, like 2 here or even more in here. And yeah, we can still use some escaping. See, this is one text block, this is another text block, this one has some escaping of tabs. Let's run it. And I have n 2 tabs and then due. And still we can use you can still use the text block like any other string. Let's say for this formatting, I can just put like a string or a digit or something else. So I can use it like this. Sorry, what's the... Yeah, because it yields about the deprecation, but this is the output. See, so I have put my name and the process ID here. And this method is deprecated. I'll show you shortly why. Okay, so this is the indentation, and how does it work? The indentation works this way. When a text block is detected or encountered, the result the compiler wants to have is that at least one line shouldn't be indented at all. Should have no indentation, no white characters in the beginning. So this is the target of the compiler. This is the rule. And if the closing is in a new line, like we had in here, for example, it counts as a new line as well, basically. So in this very example, sorry, let's not skip it. And all lines with empty spaces aren't taken into account. So if I have empty lines like this line here or this line here, it's not taken into account, basically, when it comes to this indentation calculation. And then all trailing spaces also get removed. So when I have trailing spaces, like if I put trailing spaces here and we try to print it, let's print it. See, I have no empty characters here. It's just a new line. I have no empty characters here. They just get removed. The trailing spaces. I don't know why they get removed. And all white space characters are counted equally. So because they had this dilemma whether there are spaces or tab characters in here. So the rule they came to says one white space character is one white space character. It doesn't matter if it's a space or a tab character. One is one, and that's it. So like 4 spaces count as 4, and 2 tabs count as 2 white space characters, basically. And the rule is this: when you have a multi-line text block, all the lines are being selected, and this is not exactly the algorithm, but this is how you'll get the same result. All the lines are taken, and the compiler checks if at least one line, which is non-empty, starts with a non-white character. If it doesn't, then it removes the first white character from every line and checks again. It tries to push the whites, all the lines to the left, one by one white character by one white character, until at least one line has no white characters. This is the rule. So when you take like an example like this, why it's not indented, it's because we have 2 lines in this block. This is one line, and this is another line. And here we have moved this closing along with this text, right? But in here, this is a new line starting here. So we have this indentation, and this is a new line starting here without indentation. Okay, so when I do something like this, you see it's like we have this indentation here and that much indentation here. So both lines are moved left this way. Like maybe I can show you like okay, this is what compiler does. So it checks and removes the first whitespace character, then removes the second, the third, the fourth, and finds that this last line has no whitespace characters anymore. That's where the process of shifting to the left ends at this moment, and that's why we keep this indentation and there's no indentation here. Okay, so there are different two competing styles. One style says that you should be manipulating this thing, and the other says you should be manipulating this thing. Like where to put your indentation. I prefer this style and to align with the closing with the opening, basically. But if you need to make it the indentation, you can also go this style. Only personally, I would say it's weird. So it's up to you. Yeah, so empty lines are kept. And so text blocks are simply speaking strings only without need for explicit white spaces, and escaping, as I have shown you, works exactly the same way. And also the concatenation, I mean, you can concatenate two text blocks like in these examples. And fortunately or not, text blocks are not raw string literals, which were planned for Java 12. I mean, a lot of folks got happy and excited that Java 12 will have raw strings. Eventually, they realized that this is not such a good idea, so they unmerged it. And we didn't have raw strings in Java 12. Some say raw strings are still in a game, only like delayed or something. We'll see in the future how it works. And also there are new methods in string which are also needed for this indentation to work. Like we have indent. So you can indent your string by this many spaces. You can strip the indentation, so you'll get basically the same what the compiler does with the text block. You can transform a string, so you can have something like this. For example, we can have like 12, and we can say transform and integer parse int, if I remember correctly. See, and I got an integer 12. So I can just put any lambda in here that will transform the string into something else, into this R type, basically. And of course, there's a method to format it. Like the formatted is what I have shown you here. It behaves exactly as the static method. Only it's called on the instance. Finally, we have a method like this, right? Because text blocks don't mean any string interpolation or something. So we still need to format the code to get like inject strings or digits or whatever. Just instead of calling string.format, I can just format on this very string. Yet this method is set as, as I have shown you yesterday, this deprecated, and it's for removal since 13. Because if they decide to keep text blocks as they are today, this annotation will get removed. But if they decide that the text blocks are a bad idea and they will kind of delete it from like Java 14 or in the future, they will delete this method as well. So this is like one of the usages of the enhanced deprecation. Okay. And there's also a method to translate escapes if you're reading like a string from a raw source. There's a very nice programmer's guide to text blocks by one of the authors of this text blocks. So see, if you're eager to learn it, to learn more, you can see, they're showing this, how this indentation works, where is it cut from, and also that the spaces count, like tabs. You see, here you have that many spaces. You have tabs here, so that's why green got indented despite its looks to be more to the right. Okay, so everything's written here. If you're eager to learn more. Okay, so do you have questions to text blocks? No questions. Okay, let's keep moving. So compact number formatting, which was introduced in Java 12. This is this ticket for it. and it goes like this. So sometimes you have like LED displays that you need to show like a rounded number, for example, and you don't need to say precisely this is like 1522. If you say like, oh sorry, it's a bad example, but if you have like 2100 and something, you can just show it's 2K, okay? So it's the compact format, and when you do something like this and you use, in some locales this would be 1K, in some other this would be 1 like for Polish, and this would be 1000 for Germany, for example. I have a code to show you. Yeah, because deep diving needs deep diving. So I have a list of numbers, basically 1000, 1 million, and 1 billion in short scale. And I have a list of locales. By the way, I was a bit surprised that Ukrainians, I mean the code for Ukrainian is UK. Of course, the country code is UA, and we have the list of these locales, and in each of these locales we want to run the or show the compact version of these numbers. So what we can do, we can of course run it and see the result. And the result is of course quite obvious. So in UK you'd get 1K, 1M, 1B. In Poland, you'll get this. In Ukraine, if you speak Ukrainian, you'll get 1 TIC. Sorry, it's not I, it's E. And in Russian, you get tis, not tis, but tis, right? Sorry for my bad pronunciation. And in Belgium, if you have like a French version, you'll get this. For Dutch, you get this. And this is what you get for German. And this is the long version if you care, sorry. So if you need such abbreviations like these ones, like in this column, you can use compact number formatter since Java 12, basically. And you just have a number format, get compact number instance for a given local, and you can choose the short style or long style to get this output. That's the whole story, I think. Yep, there's another article, and then there's a team collector. Do you guys use streams? Do you use collectors? Okay, what collectors do you use? Sorry, shut it out. I can't hear it. There's some music out there. I guess you're using toList. I guess you're using joining. And I'm not sure you're using anything else, right? Because the others are not so popular. Thing is, sometimes you need to, because Brian VMS said that during Devoxx Poland this year, and I think this was a brilliant thing to hear, that streams are not data structures. This is the most important thing you should know about streams. And the second thing is that streams aren't data structures. So you can't process a stream twice. You can't have stream processing with two terminal operations. Yet sometimes, let's say, out of a single stream, you'd like to have two results. Like, let's say you'd like to count you have a stream of numbers, and you'd like to count how many numbers you have, and you also like to get the average, for example. So, yeah, this was introduced in Java 12 to address this, and it works like teeing in Linux. So if you have Linux, yeah, you can have man t, and using t command in Linux is like, normally you can like echo or output, you redirect your output to a single file. Okay, if you want to redirect it to 2 files or more files, then you can use the T, which means that the output will be sent to many files concurrently. Like you can output like the output of a command, let's say, to 2 files, for example. And also, this is the logic behind, motivation behind the T collector. So this is the signature of a T collector. But this way it looks nicer, I'd say, right? Yeah, so we call on the collectors, we call teeing, and we have one collector and we have another collector. Both can like yield different types. This one can yield R1, this can yield R2, and eventually we need to have a merger which will merge the results of both collectors. This way, when I call teeing of a string of numbers, I can make this collector count the numbers. I can make this collector to count, like summarize the numbers, and this merger then will merge it to a single result, having both like the sum and the count, basically. Yeah, so let's get to the code. I have this thing collector because, yeah, we have a stream of numbers. Like this, we iterate from 0 to 20. I mean, just a stream of numbers, for example. And to get a sum and count, we can do it like this. We can map them to long, to make this long stream and to get the sum, and then we can count the elements as well. Only that, you see, I need to create this stream twice. So this is the waste of the CPU and stuff and so on. So in order not to do it twice, I can use reducing. So I have this count and sum simple class. See, we are missing the record types in here because normally, I mean, in the future, I'll be able just to set it to be a record class. Then I don't have to set this that it's final. I don't need to create this constructor and so on. But we are where we are now, so I have this simple class to keep both the count and the sum, just two longs, basically. Yeah. So I can use the reduce operation, which has this nice, yeah, we have the identity, we have the combiner and the accumulator. So yeah, this code is nice and easy, right? So you know that we have like new accumulator, which is not correct, by the way, because empty stream shouldn't have count set as 0, okay? Maybe it should be like optional. So it depends. It's not the best example for like business logic, but it's an example for reduction. So I take the previous count and sum, and I can reduce it this way, so I can increase the count by 1, and I add what I have to sum, and then for parallel streams, for example, I can from two count and sums, I can like merge the counts and can merge the sum, right? So we can do it in a single pass using the reduce. Thing is, it's not very simple. Or we can do it like this way, using ting. See? Then on gimme stream, I can call collect, and I pass a ting collector. And this collector, as I have shown you, has three things. Has one collector, which is just counting. I have another collector, which is just summing up, and I have the merger. So basically calling the constructor, which will take the count and the long. And this is it. So yeah, comparing this code and this code, I would say this one is a bit simpler, right? Also, I'm reusing the code I already have. Instead of this longish line, I'm just using the counting collector, which is already there. So of course we can run this code and compare the results. Yeah, so see, the sum is 190, the count is 20, and this is the result of the reduction. This is the result of ting, so they work exactly the same way when it comes to results. However, be aware that sometimes you don't need to reinvent the wheel. You can just use this summarizing long collector, and it will give you these stats. See, so this example wasn't even needed. I just yeah, for demo purposes. And with ting, we can do even more, because see, I can have, like this time I didn't use or create any pair, so I have this just the array of two elements because we don't have unnamed tuples in Java, so many people use this construct. It's not the best, it just serves a purpose. And I'm using this collector because I want to count in my stream how many numbers divisible by 2 I have and how many numbers are divisible by 3. So instead of like filtering this stream once and then creating another stream and filtering it again, I can do it in one pass using ting collector, because now I'm going deeper and deeper. I'm counting the numbers which are passing this filter. I mean, they're divisible by 2, they're even. And here I do the same for numbers divisible by 3. So in fact, I'm using 3 collectors. But I don't have to use the reduce and so on. So I'm collecting using ting collector, and I'm filtering and counting the numbers that pass this filtering and so on. That's why I know there are 10 numbers 10 even numbers from 0 to 20, I mean up to 19, and there are 7 numbers divisible by 3. Using this simple construct and ting, because previously I would have to use reduce for this. Thing is, ting is extremely useful if you have these collectors already, because you don't have to reinvent the wheel, you don't have to re-implement that or write it from scratch. If we have the counting collector and filtering collector, why should I express the same logic as reduce? This is like, following this solid and single responsibility and don't repeat yourself principles. Because if we have this counting and filtering, why should I create the same code again and again? So let's use it as inside ting collector. And I quite like it, this approach. Yeah, so do you have any questions to ting collectors? There's one question. Because of the signature, the question is why I choose... Sorry, can you ask? Yeah.
Yeah. How? Yeah. Why the merged result is not the first, the parameter, and the others could be the last, like work arc, and we could use a lot of...
I'm really sorry, because of the echo, I can't hear the question, so if you could just ask louder.
Yeah, the merged result is the last, yes? Function.
This?
Yeah. Why not? It's not the first, and the others would be with like work arc, lots of them, so we could collect a lot of results and then merge it together.
I mean, this is just the signature of ting. I mean, if I get the question correctly, because it might not be the case with the echo. So it's basically, this is the first collector, and I'm able to use only 2. This is the first collector, this is the second collector, and this is the merger. So in this nice example, as a merger, I use the constructor of this count and sum recordish or tuplish class, okay? And in this example, I didn't create such a class, which is shame, because I should have. It's just I'm using, as a temporary accumulator, these 2 elements long array. And that's why it's here, because it's of the signature of this collector. So this is the last parameter, and I'm just using lambda. So when I get one long and another long, I would just yield a new 2-element array of longs.
Yeah, question is, wouldn't it be in future more flexible if we could collect a lot of results? So not only 2, like for example, 3, 4, or 5.
I mean,
in the one,
this will work as well, because okay, they are not having more and more like the signature for ting for 3 or 4 or 17, but you can nest them if you really need them. Yeah. Thing is, if you really need to collect 3 things, maybe ting is not the best option. Maybe you should consider reducing, because in such case maybe reducing would work. I mean, I don't see any reason why we shouldn't like t inside t. We could do that. It could be maybe awkward. So that's the answer. Basically, we don't. This is the signature we have. We don't have a signature with like downstream 3 and then merging 3 results or something. We could maybe you could create such a method for yourself. I mean, static method. Why not? Yeah. Okay. So we were there. Yes, that's the ting collector. Yeah, another block entry for this. Another new method we have in files. It's called files mismatch. It was introduced in Java 12. This is the signature, and this is how it works. But let's go to the code. Files mismatch. So basically, basically I have 2 text files, text1 and text2, and when I call, of course I need to get paths, because the files mismatch is using paths, and it will yield me -1 if the files are identical, I mean byte by byte, or there is a difference, it will give me the position of the bytes. So I have the files near, like this, like text1, and this is like, when you're testing a font in Polish, you usually use zarzuć gęślą jaźń, because it has all Polish diacritics. And there's another file called text2. and it looks pretty much the same, right? So we can test these files. If they're really the same, we can call this, and let's see. Nope. It was detected that there is a difference, like there's a difference since byte 21. So we can compare these files because I think it's like, for some people from, let's say, the Western world, I find this a bit, I mean, they find it a bit shocking. I find it shocking that they find it shocking. See, there's a difference at this character. Any idea where there's a difference? You should know. Sorry? Yeah, exactly. No, pass it back, thanks. Exactly, so this is Latin A, and this is Cyrillic A, right? So it looks the same when you print it, but deep there, when you write it as UTF-8, of course the bytes differ. That's why a file mismatch will pick it up. So if you want to just check if two files are identical or if they're different and what's the position of the difference, you can use file mismatch since Java 12. Okay. Completable future with better error handling. Who's using executor services or completable futures and stuff like that? Quite many folks, okay. So now we have better handling of exceptions since Java 12. And yeah, this is nice articles describing this. So basically we have these new methods. Yeah, nice and easy, right? So how do they differ? Like we had the method called exceptionally up to Java 11, and we still have it. Now we have these methods called async here, which will handle this throwable, and with this function, either this and this, and in this overloaded variant, we can even pass it to another executor. So we can have a handling of an exception from a completable future on the other executor, and this will be asynchronous. We can compose asynchronously, like one of the features, completable futures, throws an exception. So then we can start another like completion stage or completable future, and using this function fn. And in this very last method, again, we can do that using a separate executor. So this is the reason or the logic behind this new 5 API methods. So we are able to handle exceptions in a synchronous way, or react to exceptions in a new completable future, and we can also do that using a new executor or different executor service. Let's say normally you handle your business logic in a synchronous way. It's just when exception happens, you want to have to pass it to another execution service, which, for example, might be single-threaded because there is no reason to have more threads because you're going to send emails anyway, and you can't spam the server. So sometimes it makes sense, right? So now it's simpler. It got simpler. So let's take a look into the code. So we have this completion stage demo. Okay, so let's run the first method, which is demo exceptionally, which is running the mechanism we had up to Java 11. And of course, we still have it. So we have this asynchronous behavior, and of course it's going to blow because we're going to divide by 0, right? And even IntelliJ is so smart, it already says so. But let's say we are colorblind and we don't see this warning. So when it blows, we can exceptionally do something. We can say we're handling this exception and return 0 to just return something, and then we accept the result either from this or this when an exception happens. And one thing you should notice is just everything happened in the same worker and in the same thread ID, because we are not using any custom execution service. We're using the default fork join pool, right? That's why maybe you'd like to use not the default fork join pool, also because parallel streams are using it. And the other thing is, like, the name might be not quite okay. Like you'd like to have your thread factories, your own thread factories, just to name the threads. Okay, now we can do this exceptionally async. Let's run it. See, and it's just it's the same code, only I'm calling exceptionally async. So the handling of the exception will be done in an asynchronous manner. So see, then the handling of the exception will be given to another thread. And I could even pass it to another execution service, right? So now I'm not only doing the success path asynchronously, I can even handle errors in an asynchronous way. And if you have like a fallback plan, so we have this exceptionally compose like this. See, we have plan A. And if the plan A blows, then we start with plan B, basically. So we have like plan B. And this is the final plan. So our final plan is plan A. And when something exceptional happens, we compose it with plan B. In this exceptionally compose, we return another feature, which is going to be used, right? So this is the returning plan B, basically, and this is just debug. Let's run it and see. We are doing something. Sorry, is it like correct? Yes, it is. So we're doing something because, of course, this plan B is triggered even before on the fork join pool, but we have this plan A just blown up. Because we have this array index out of bounds. By the way, do you see how this IDE is smart? I'm dereferencing array in an array, and it knows it's going to blow. Really good job, I mean, for the IntelliJ folks. Anyway, I have this plan B, so when plan A, something went wrong, I'm returning plan B, so it's not returning me a random integer or just integer of this scope, it's returning -1. So see, in this final plan, we have then applied, so we double that, that's why we got -2. So our plan A didn't work, so we compose it with plan B, and that's why we got -2. And this is done everything with thread 19 when it's working, and we have asynchronous. Then see, it's going to another thread. It's like in this very case, it's flipping between these two threads. But as you could see, it didn't continue with this 19. It continues now with 5. Instead of because the thread 5 was idle, so it selected it again and so on. But this is the way to also asynchronously combine the futures, right? Yeah. So any questions to that? Basically, it's asynchronous exception handling or exceptional future starting for if something goes wrong. The socket API got re-implemented. Like the previous socket API was using not so nice code since Java 1.0, and it was a mixture of Java and C, native C, let me put it that way. And it got re-implemented using NIO. And this NIO socket implementation should be a drop-in replacement for what we had before. Because the guys who re-implemented that not only obeyed the Java docs and method signatures, what they also did is they tried to, as much as they could, mimic the unspecified behavior. But sometimes some people were overusing or abusing the behavior of plain socket implementation. So for them, things might blow. That's why you can use plain socket implementation system flag to say that you want to use the old version instead of the new one. So in Java 13, we have this socket demo. So let me edit this configuration. So we'll use Java Unified Logging to see what classes get loaded when I run it in Java 13. Let me run it and see in this output I have NIO socket implementation being loaded. See the class. This is the class that got loaded, and as a fallback mechanism, you can say that you're going to use this plain socket implementation, despite it's Java 13 and onwards. So then when we run it, and I say NIO socket implementation, it's not there. It's plain socket implementation being loaded. See, so we're still using the solution dating back to Java 1.0. If you really need that for your network applications due to whatever. There are also changes in garbage collectors. I mean, sorry, where shall we stop? I mean, maybe I'll check the agenda. Sorry? What a lot of time meaning precisely? Ile? So 50 or 30? 30, okay, so we have half an hour, thanks. Okay, so there are changes to the garbage collectors like G1, Shenandoah, and ZGC. So changes for G1 in 12. Now we have abortable mixed collections for G1. So in general, G1 is dividing the memory to collect into some areas based on some heuristics. It's just, heuristics are kind of a cache. And sometimes the cache is wrong and needs to be invalidated. So previously, when the size of this area to be like, let's say, compacted or evacuated was too large, then the G1 was still doing that, and you ended up with extremely long GC pause. Now G1 behaves in a way which, when it detects that the time specified by the heuristics, by this cache, is actually the job is taking more time, it aborts this collection and will continue in a next cycle, in the next pause. So that's why we won't get such a long pauses if the heuristics were wrong. So this is the improvement to G1. And the unused memory is promptly returned to the operating system from G1. There was a very nice test performed by Bruno and other people, and they created a paper of it. And this is the important part. The important part should be Tomcat, HTTP, and Night VM by 85%. So they performed this experiment, and they've seen that during the night time, when the Tomcat is not receiving so many HTTP requests, the JVM was able to give back to the system 85% of the memory. So, for example, if you're running your Tomcat in cloud, you don't have to pay for this memory during nighttime, where you're not using it. Another great feature, just to have a cheaper cloud applications, for example. So this is the real outcome of this change or enhancement. There is a new garbage collector from Red Hat. Who has heard of Shenandoah? Okay, so both Shenandoah and ZGC, because there are not so many hands raised, are concurrent garbage collectors, meaning they will run concurrently with your application threads. So there should be no this freeze everybody phase. Right? But just, when they are running things concurrently, some stuff might get obsolete, so they're addressing it in a different way. ZGC is using this coloring of the pointers, and Shenandoah is using forwarding pointer. Anyway, the motivation is to have a concurrent garbage collector. And if you'd like to use both of them, I really recommend you should try the Adopt OpenJDK build, because as far as I know, Oracle is not so eager to merge Shenandoah into their OpenJDK, because they don't want to be responsible for Red Hat's experimental garbage collector, because both are experimental for time being. Yeah, it's experimental, and Shenandoah got introduced in 12 by Red Hat, but the guys did really good job because they're backporting it even to Java 8. So even if you're running Java 8, you can use Shenandoah 1.0, and maybe they will merge down Shenandoah 2.0. This is this JEP. And this is how you can use it. You need to unlock experimental features, and then you should say that use Shenandoah garbage collector. There's a very nice wiki page describing the motivation, how it works, and so on. Let's see this wiki page if it loads. Yeah. So you'll see these forwarding pointers, how they evacuate the memory, the compact memory, and so on and so on. So really nice page. Really, guys, we should read the documentation sometimes, because few minutes of reading can save you a few days of writing. Really, this is how it works, right? So reading before writing is a good habit, I think. I really recommend it to all software craftsmen and craftswomen. So yeah, there's a very nice talk on Shenandoah by Alexei Shipliev, a garbage collector that could. I recommend this talk. And it got improved in Java 13 as well, because now they're supporting pretty much everyone, even Windows and even 32-bit architectures. And yeah, they have this load reference barriers, and they eliminated the forwarding pointer words, so they don't use more memory than previously. And there are also other, they're respecting minimum heap size, so they won't give more than the minimum heap size back to the operating system and so on. So the guys from the Red Hat are really doing great job on this garbage collector, and it's really worth trying, like in Java 12 or 13, as you can see, because it's improving. And they realized or implemented all these tickets, if you're eager to read that much documentation. Okay, the other garbage collector, ZGC or ZGC, is from Oracle, and it's also experimental. And it got improved in Java 12 and 13 because it got introduced in Java 11. And yeah, again, there's a wiki page of ZGC. You can see that. And yeah, in Java 12, finally, class unloading works. So when the detect or garbage collector detects that the class is no longer needed, it can be unloaded if you tell it to do so. And they introduced a new parameter in Java 13, which is called soft max heap size. So because we have these two parameters for Java runtime, like minimum heap size and maximum heap size. And they introduced something in between, like this soft max heap size, meaning that the ZGC will try to obey this soft maximum. It will try to just to not to go above this soft heap size to max heap size. If it fails, of course, then instead of throwing out of memory error, it will occupy the memory up to the this max heap size. But this is like the soft limit you can set. Like try to be aggressive before reaching this limit. Okay. Not only just before the maximum heap size. So this is a great improvement. And yeah, now that we can use the extremely great heap sizes up to 16 terabytes. And whether you use Shenandoah or ZGC, both, as far as I know, are very efficient. I mean, I don't have such huge heap size, but the reason behind those two garbage collectors is that they should have really small, predictable garbage collection pauses, even for huge heap sizes. Like the maximum target for ZGC is like the maximum pause should take no more than 10 milliseconds. Right, and with like let's say a few gigabytes heap sizes, they have on average 2 millisecond pause. So not 30, not 60. Sometimes like we have with G1, if the stats are really bad, but like 2 milliseconds are really low latency, I would say. So to use it, you can set again that you want to unlock experimental VM options and use ZGC, and of course set maximum heap size, and you can also add this soft heap size and so on and so on. You can also specify the number of concurrent threads, as far as I know, and so on. Yeah, there's a talk by Erik Österlund on Z garbage collector. Of course, there are more talks, but this one is nice. Okay, so there's also a constants API. Which was introduced in Java 12, and it has something to do with the constant pulse of the classes. And I'm sorry, that's pretty much I know about it. Yeah, I'm not going to dive deeply into this. And application class data sharing, which is improved with every version of Java. So in Java 12, because how did it work, let's say, for Java 10 or 11? You had to create a list of files. Okay, let's start from the beginning. Do you know what class data sharing is? In general, anyone knows? Okay, so the story goes like this. I will oversimplify, but this is how it works, more or less. When you spin off or start your Java application, the whole class path has to be read by the class loader /bootloader, right? And then just like Tom Cruise in the Minority Report, it's reading all these classes from all these jars, from all these files, and it puts the classes and methods and everything into this in screen, and everything is set. So during the runtime, it's known which class from which file, with methods, and so on, basically. And the thing is, when you spin off the same application 10 times, 100 times, the JVM is still doing the same job. Even if you don't change your application, even if you don't change a single byte in this class path and your own code. So why not to cache the result of this process, right? So that's why the class data sharing was introduced. So this whole result can be simply dumped to a file, and when you spin off or start this application again, JVM can just check this file. It can see, okay, I have this file, so I don't have to build this image again. I can just load it from this file. And it goes even further. If you have more instances of the same application, the processes will share in read-only mode this area of the RAM, basically. So let's say if you have 100 JVM instances running the same program, then you won't have, each process won't have its own area for this class data. They will share the same area in the read-only mode. So basically this acts as a cache. So when you have Lambda style serverless microservices, this basically may save you quite a lot of time and memory and so on. This is basically to first reduce the boot up time or class loading time, to be precise, and second, to reduce the memory footprint, because now this memory is shared among many processes, basically. And how it was done in Java 11. First, you had to create the list of the classes that are going to be loaded, or you could ask JVM to log the list of the classes it's loading. Basically, you had the text files with the classes. Then there was a second step. So the JVM was building this class data sharing archive file, basically meaning dumping this whole memory to a file. And then in the third step, you had to load this and use it just during the normal usage, right? In Java 12, this got improved because we don't need to create this default archive for JVM itself. Now JVM since 12 comes with this predefined archive. Previously it was the installer's job. Now even if you download the zip, it will be there. And what they improved in Java 13 is just we can have this archive created dynamically at exit. So instead of these stupid manual steps in the beginning, all you can do now with Java 13, you can say, okay, when you exit, please, instead of just releasing this memory before you release it, please dump it to a file so I can use it in the future. One important thing when it comes to application class data sharing, or maybe two. First, it's class path based, so your class path needs to match, at least the prefix has to match. So when you change something in the class path in the area that was covered by class data share archive, it will blow. And the second thing, it's a implementation, or de facto it works as a cache. So it's one of these two famous problems in IT. You need to know when to invalidate your cache, right? So when you have a new class path or changes in the application, you should get rid of this class path, basically. Okay, so let me cover that. I should have a code in Java 13. Yeah, so I have a simple script. By the way, if you ever intend to make a benchmark, this is not how you should make benchmarks, okay? This is not a proper benchmark, scientifically approved or something. This is just to give us a rough idea how stuff works. So this is a simple script. This says that it will blow when the first error is encountered, of course, and we remove this dynamic archive. And what we do, we first create this dynamic archive in this step. So we use this new parameter from Java 13, and we say when this application ends, please dump all this class data sharing archive to this file dynamic.jsa. And then we disable class data sharing totally. like even the one that comes from JVM or with JVM, and we measure the time using this time command. Then in the next step, we are running our application using the default class data sharing archive which comes with JVM. And then in the next step, we're using this dynamic one, which also covers our application. Okay, so now I will try to run this script. Where are we? Okay. Sorry, I need to go to src main Java. Sorry. cd. Yeah. One thing for you to note, I'm not using Java-C and Java for simple applications. Please, guys, remember that I can just call the JavaScript, right? So I'm just using Java, and here's the Java file. So it will compile it under the hood and run it. Okay, so let's run this script. Yeah, so this is the output, and basically we should be looking at the real time. It's like the clock wall time. And when we created this archive, it took like half a second. So running without class data share enabled is like almost 400 milliseconds. This is the time that has passed. When we enable the default one, yeah, this is not a proper benchmark because of the warm-up and so on. So let's see if the next result is more like up to the idea. Yeah, again, still it's a little bit longer. Like normally it should be a bit shorter, but it's like difficult. You know, the glitches are so slow. So sometimes this is slower, faster than this one. Sometimes these are equal. But when we enable this application class data share archive, I mean the one for our application, you see it almost always gets lower, and it will get lower and lower the more classes you have. I mean, the bigger application you have, also in terms of the frameworks and libraries you load in a class path, then the better boost you'll get here for this time, basically, because this is like tiny application. It has just one simple hello world, so it doesn't do anything. That's why, you know, these glitches are possible. That's why it's not a proper benchmark. And yeah, so there's more to cover, but actually I was planning to have a break, but I know that breaks here are not a good idea because everything is crowded, so I think we'll just finish a little bit earlier so you have time to grab your coffee and refresh. Of course, there's more to cover. That's why you should, again, read the freaking manuals. For example, if you're using Swing applications, they will not render properly on new Linux using GTK since or from 3.2. However, they managed to fix some other issues, like now hidden directories in Windows are really shown as hidden because previously it worked only for files. Of course, they have updated and removed many CLS/TLS certificates because there were changes, like in the root CAs and so on and so on. So now this got addressed. Of course, this new Japanese era and so on and so on and so on. But these were the most significant changes, I'd say. What the future brings, I really recommend you should take a look at these three projects. So Project Amber, Project Valhalla, and Project Loom. And yeah, as Kai Horstman said yesterday, really, it's interesting to see what's going on there, to provide your feedback, because Project Amber is about like little everyday improvements, like these record types or the vart local type inference and so on. Loom is about having these fibers/threads, because I don't even know if they agreed finally how it's going to work. Valhalla is about the generics reification, so at runtime we should know more or less like in .NET that, let's say that this is a list of strings, not just a list of something. And also we could have value objects, meaning we could create classes which would behave just like primitives, and this would be extremely useful for example, arrays. Because currently, how it works, what's the memory representation of objects stored in an array in Java? It's array, what we have one by one are the references to the objects. When you keep integers, there are just integer, integer, integer. But when we keep objects, you have a reference to an object, reference to an object, and reference to an object, meaning that the reference can point to another address somewhere there in heap, which means that when the CPU tries to load this array, for example, it can't load the objects like to the cache in a one nice loading. It just loads the references. That's why it's quite slow. But if we could put to this array these objects one by one, and this is what value objects are for, then we could significantly boost the way we process our objects in arrays in Java. And yeah, this is the news from last Tuesday, October 29th. So the JAB 359 for the records you see for the hotspot, reflection, compiler, and Javadoc has reached the more or less the code review phase. So I really hope we'll get the record type for Java or with Java 14. So this is one of the changes that may come. They call it this way that this will be kind of a just like tuples work, only in Java we will have named tuples because they want everything to have its own name, just like we have with this functional interfaces and so on. Дуже дякую. Thank you very much for attending this deep dive. And again, guys, you have heard